This is the prep packet video for Unit 4, Chapter 9.1. This is for objective number 1. In this particular objective, we're working to find square roots and something called principal square roots. And what I'd like you to do before we get started is work with me, and I'm going to go through some of our vocabulary. You probably already know what a square root is. That's the idea that if I take a number, n, and I multiply it by itself, I'll get n squared. If we start with something like x squared, if I do the inverse, the square root of that would be x. When we talk about principal square roots, it's always the positive one, but I'll talk a little bit more about that. Perfect squares are just like it sounds, it's perfect. So I have 6 times 6 equals 36. That's a perfect square. So if I'm looking at this, that will give me a whole number. If I look at this, that won't give me a whole number, so that's not a perfect square. Rational numbers are numbers that have a place on the number line. Whole numbers are an example of that. Fractions and decimals that don't that repeat or actually come to a terminal ending. So this is a rational number. This is a rational number. That's a rational number. Real numbers are all the numbers you've ever dealt with. We'll talk about unreal numbers in a later chapter. Irrational numbers, those are a little bit different. They don't really have a firm place on the number line because we haven't really figured out quite exactly where they are. An example of that would be pi, which, as you know, is 3.14 and an as yet undiscovered infinite number of places. Another irrational number is the square root of 2 because that repeats. Let's talk specifically about these because this is some of our, we're going to be using these words a lot. So we talk about the radical sign. That's sort of like a division sign, okay? The whole thing is the radical, and the number inside is the radicand. And all of this has to do with roots, and you may be wondering why there's a picture of a radish up here. Some people might think that's a beet, but it's a radish, doggone it. And the reason I chose that is that I wanted you to notice that, and that. They're all tied in with the word root. Okay? That's just kind of an important thing I wanted you to know. A little vocabulary for math. So if you want to copy any of that down, you can. You know how to do that. I'm just going to buzz through this. These things are in your book too if you want to take a look at them. So we talk about radicands, and if it's a perfect square, it's a rational number. And remember, that was something that's like a whole number that's right there on the number line. When we use this, which is the, remember, radical sign, it represents the positive square root. And this is another vocabulary thing that we use in this chapter. The positive square root is called the principal square root. I know that you may realize that the square root of 25, sometimes you could say it was positive 5 or it was negative 5. For our purposes, we're going to be talking about only the positive 5, which is the principal square root. We have other ways of writing that. Radicands and square roots. If the radicand, which remember is the thing in the middle, the inside, so write this in here is the radicand. If it's negative, the root is not a real number. So don't go too far with this. Again, in later chapters we'll talk about what happens with those. It's actually an imaginary number. So let's keep going. So if the radicand is positive and not a perfect square, then it's an irrational number. And the square root of such an, well, you can read this just as well as I can, but here's the basics that you really need to know. And this part, we didn't talk about what this part of this sign is. This is called the index, and that tells you how many roots to take. So most of the time when there's nothing there in the index, that's because it's a square root. We don't even bother writing that because that's a very common thing. But you could have x, the fourth root of x. You could have the 93rd root of x. And it's important to pay attention whether these are negative or positive, and you'll see that in a second. So if the index is an even number and you have a positive radicand, you're just going to use the principal root, which I talked about before. We're not worrying about plus or minus right now. But if you see even and positive, but there's a negative sign out in front, then it's the negative root. And that's how we write that. And we'll practice that a little bit more. And the other thing to remember, if this is even and this is negative, it's not a real number. So you can kind of stop for now. It's not a real number. You can have an odd index, like if I were asking you for the cube root, and the answer for that, there's only one root for that. All of this seems kind of goofy right now, but as we practice it, you'll see that it starts to make a little more sense. So again, take any notes on that you need, and let's move on. So here are some exercises. Here it's asking us to find all the square roots of 81. And if you're not too good at roots at this point, I do have a chart I can get to you that will sort of help you with that, but it's kind of a good thing to know at least your basics. So the square roots of 81 are, let's see, what number times itself makes 81? Well, that would be 9, positive 9, and negative 9, because negative 9 times negative 9 is 81. These are all the square roots. If I had just asked you for the principal square root, it would be only the positive one. So let's do some of these. Let's see. Here is the square root of 16. Again, the index is invisible because it's understood. And the square root of that would be 4, positive 4, and negative 4. And I care about the principal root. For number 3, I'm going to take the root of the inside first, so that's the positive principal root would be positive 3, but there's a negative out in front. So that's telling me to take the principal root and do the opposite, so that would be negative 3. Remember when you have, let's look over here, when you have a fraction under a radical, you can do this. And we're going to start using just principal roots here. That's a perfect square, so that's the same as 6 over another perfect square would be 7. Here, again, I'm going to take the principal root of 100, which is 10, and the principal root of 9, which is 3, and I'm going to do the opposite. Now, let's take a look at this one, because this is kind of strange. Remember, here I have a square root sign, so my index is even, because it's secretly 2. But I have a negative inside, so let's see. If it's even on the outside and negative on the inside, it's not a real number. So you can stop there. Don't try to hack away at that. Only if the negative sign is on the outside. And that's the speedy version of objective number 1. Please stop and copy, and I'll see you on the next video.